Okay, today is a little bit of a review for the cumulative assessment, and let's do some practice problems here. Let's say we had absolute value of 2x plus 1, and let's say that that was less than x squared. Now, first thought I'm hoping that you have is, could I use a calculator for this? Because you can. There's part of the test where you can use calcs and part where you can't. This is the kind where you'd have a calc. And if you were to graph this puppy, would you be looking for places where they cross? Yes, they're important. But then you would also be thinking, I hope I've drilled this into your head, ooh, that looks kind of like the end of a number line. That's what you'd be thinking when you see one of those less thans or greater thans, because you'll need a number line. However you want to remember it, when there's a less than or equal to, or a greater than or equal to, or a less than or a greater than, you need a number line. And you'll find a couple points on that number line. And then you can either just use your calculator to tell you where it works, like it works in here and it works in here, but not right there, that kind of stuff. Or you can test points. You can still test points, and that works fine. All right, so try that. Graph it with your calculator. If you don't have a graphing calculator, borrow one of mine. Don't just sit there. All right, I'm going to pause while you work on that one. Just a quick reminder, in case you haven't already, I would call this one y1. I'd call this one y2. And then a third line on my calculator, I would say y1 is less than y2. Remember, that's found under catalog on your calculator. Catalog button's right above the 0 button. Okay. Now let's be realistic and see how many of you would have at least gotten the 2 points right. Okay. Once you graphed it with your calculator, you use second calculate intersect, and you'll see where the V shape touches, this is the V, touches the U shape. So basically it looks something like this. There's a V shape that's been shifted to the right, and it's a little bit narrower, so it looks kind of like this. And then there's a U shape that looks something like this. Does it touch twice? Okay. Does it touch at, what are the two numbers? It's 1 point something, I can't remember. What are they? Negative point 4 something? 1 4 or 4 1? 4 1 4. Okay, thank you. And then this one is positive what? 2 point what? 4. Okay. Raise your hand if you were able to ascertain that those are the 2 points. Okay, good. All right. Look at your calculator. See if they actually is your calculator telling you where to shade? It is if you typed in this line. Your calculator should be telling you where to shade. But if you don't know how to do that, you can at least, if nothing else, test points. So I'm going to test a point like, what's bigger than 2.4? 3. 3 should work, so I'm going to test 3 and see if it works. I put in a 3, and I put in a 3, and I see if it really comes out to be true statement or not. 2 times 3 is 6, 6 plus 1 is 7, absolute value of 7 is 7. Is 7 less than 3 squared is 9? Is 7 really less than 9? Yeah, so it works there. So if you don't know how to get the calculator to tell you, just do this kind of a deal. How about the point 2.4 itself? Does that work? No, so you have an empty spot. Why do I know that? Because this is a less than sign, it does not have an or equals on it. How about this in between area? My favorite thing's in there, 0. I'm going to test my favorite things. 0 and 0. And I have 1 is less than 0. 1 is less than 0? No, it's not. So it doesn't work in there. Doesn't work in there. And then how about the numbers like negative 10 or whatever? Did you test those? Did they work or not? They work. Okay, so your calculator should have told you by this little, when you see your graph of it, oh, here's my graph. It should have a little thing on it that says that it worked from here over. It's like right near the x-axis. And then it has another thing from where they touch again, like says from here over. So basically it's shaded on the outsides. Raise your hand if you would have had that one right. Okay, good. Let's try another one. I'm going to try to translate what I say, and then you can use a calculator to solve it. You've got a larger number and a smaller number. In fact, they are both even numbers. I have two even consecutive numbers. So like if it was 12, it would be 14. Or if it was 8, it would be 10. Okay? Two consecutive even numbers have a sum of 24. 26, sorry. Sum of 26. How would you write an equation for that? Two consecutive even numbers have a sum of 26. All right, the first thing you got to know is how do you write consecutive even numbers? If you pick one of them to be n, you cannot pick the other one to be n. That would mean you're saying they're the same number. So if it's going to be consecutive even numbers, it has to be bigger. How much bigger does it have to be? 2. So you should n and n plus 2. Those are your two numbers. You get that? Now, what did I say about them? Add, subtract, multiply, divide them. Add them, because I said sum. The sum of them is equal to 26. All right, that was a fairly simple one. Now I just have to solve it. That'd be 2n plus 2 equals 26, and then it would be 2n equals 26 minus 2 is 24, and then n is equal to 2 times what makes 24? 12. Raise your hand if you had that one right. Okay, good. Now, here's the hard part. What if I had said, what are the two numbers? And you said, oh, n is 12. You get how you're going to get it marked wrong? Because they want the two numbers. So then you have to test and find out, is it 12 and 10? Or is it 12 and 14? How do you know? Because they're consecutive even numbers. It's either going to be 10 with it, or it's going to be 14 with it. Well, which ones actually work? They have to add up to 26, right? 12 and 14 add up to 26, therefore it's 12 and 14. There is your combo. Get that? If I actually add up 10 and 12, it doesn't add up to 26, does it? That's why 10 and 12 couldn't have worked. But be careful. You solve for it and you just get 12, and you can't just write down 12 because they ask for two numbers. Two consecutive even numbers. All right, next kind of problem I want to practice with you is, let's make sure you can do regression equations. So let's say that I have this in 2012, 2013, and 2014. Actually, I don't even... I'm going to make it one more. 2011 in front of it. Put this info into list 1, L1. Sorry, 2011. Okay, so 2011, 2012, and 2013, the stock market, let's say that it was at about 13,000 here, about 14,000 here, and 15,000 here. This is the Dow we're talking about. Then make a prediction in the year 2017. What will the Dow be at? So remember, this goes into L1 and L2, and it's under the Stat button on your calculator. You're doing what's called a regression. So when you calculate, you go second calculate, you should get an equation, and from there you can stick the number 2017 in somewhere. I'm going to pause for a minute while you work on it. Okay, for a quick check on this one, after you did second calculate or lin reg, did you type in L1, comma L2, comma Y1? That's the right way to do it. That way this equation gets put into your Y1 equation. Yes, sir? If it says quit, if it says there's an error, that means there's probably something on your L1, or excuse me, on your Y1. Look on the calculator, look in Y1. Is there already an equation there? You have to clean off the equation that's there. Otherwise, your calculator has nowhere to put it. I wish it would just replace whatever equation you used to have there, but it won't. So if there's already an equation on your Y1, then the whole thing crashes. So try it again after you clean off your Y1. Good. Yes? L1, comma L2, comma Y1. Yep. L1, comma L2, comma Y1. All right. Those of you that are confident you put your data in right, could somebody raise your hand and then tell me the equation? It's y equals something. What'd you get? 1000x. 0, 0, 0, 0? Like that? Okay. Can anybody verify that they get the same thing? Okay, good. Lots of heads nodding. That must be right. So then, the last part of the question would be make a prediction. Did this number match up better with an x or a y? That's an x, so therefore we plug it into x. Now if you want, I'm going to just show you the easy way, which is not using the calculator. You go y equals 1000 times x, which we just figured out was this, 2017, minus 1998000. Now if you want to do it with the calculator, you'd have to say, you have to tell the calculator you want x to be 2017. I don't know if you remember this. You go 2017 STO, S-T-O, store it under x. And then you ask your calculator what y is again by typing y1. If you remember that, awesome. If you don't remember that, that's okay. As long as you can take your equation and stick in the number they give you, they'll either give you an x or they'll give you a y. And then you stick it in the right spot, either there or here, and you solve it. Yes? Good question. The time, if it's ever time, that's the x. And that's almost always what they're going to be using as time versus something else. If they don't do time versus something else, then you just got to look at the number they give you and figure out if it's more like the left column number or is it more of a right column number. Like this is an amount for the Dow. Let's say they had said, when will the Dow be 21,000? That looks more like this column here, so that would be a Y number they gave me. So you just look at the data they give you as the prediction thing and see, is that number they gave me more like my Y's or more like my X's? And then you'll know if it's more like an X or a Y. All right, let's try another kind of problem. Let's say that you had another one of those deals except you couldn't use the calculator. What are you going to do if you can't graph that? You could graph both sides, see where it crosses, but there's no calculator on this one. So what are you going to do? Just try solving this. And yes, there'll be a decimal involved, but it's simple, so you can live with the decimal. Remember, no calcs. Okay, either you remember these or you don't. Divide by 2, x plus 4, 3.5. That's what half or 7 halves is. If you wanted to use 7 halves in the problem, that'd be fine. This you just split into 2. It's x plus 4 equals 3.5, just like it reads, and x plus 4 equals negative 3.5. Why? Because what's underneath here has to either be 3.5 or negative 3.5. So that's what we're doing. We're setting it equal to 3.5 and negative 3.5. Okay. Then solve it. Subtract 4 from both sides. X equals negative 0.5. A negative a half. Raise your hand if you had that one right. Awesome. And then the other side, minus 4 would be x equals negative 7. Raise your hand if you had that one right. Okay, awesome. Oh, point something. Sorry, that's right. It's a 0.5 there, so I deleted it by accident. So it's negative 7.5, right? Okay, good. All right, thank you. So go back in time. Let's say the same exact problem were given to you, except with one little exception. What if it had said that? Then what would you do? We already figured out our two main numbers, but what do we do? Number line. You should be thinking of that as the end of a number line. So it reminds you that, oh, I make a number line, and I put what two numbers on it? We already figured them out. Negative a half, and what was the other one? Positive 7.5? Oh, negative 7.5. So then I better reverse it. Say negative 7.5 here and negative 0.5 there. Then test your intervals, and then figure out if these points themselves actually work, and so it should be filled in or not. Okay, I'm going to give you a minute to do that. Give it a try. Okay, let's go a little further with this one then. I know these points work right away. Do you know those points work right away? Why? because it says or equal to. Yes, in this sign right there, it says or equal to. So they will work. If you're not sure, test them. Stick the numbers in, and it'll turn out to be equal to each other on both sides. And then you'll realize, oh, I guess it works. Now I can test some points in between, like my favorite thing, 0 or negative, let's say 3. Well, no need to make it a decimal or complicate it. And I'm going to try 0 first. 0 plus 4 is 4. Absolute value of 4 is 4. 2 times 4 is 8. Is 8 less than or equal to 7? No, that didn't work. Didn't work here. I bet it's going to work inside. I'm going to test it, though. Negative 3. Positive 1. 2 times 1 is 2. Is 2 less than or equal to 7? So it works in there, and I bet it didn't work out here, did it? Okay, and it did or didn't? All right, good. But you should check it because, like on our last test, I think we did one where it works out that way, where you can't just assume if it works on the inside, it doesn't work on both ends. Because last time we made one that did work on the end, you know? Never assume. So I'll show you. I would test negative 9. Negative 9 goes in here. Negative 9 plus 4 is negative 5. Absolute value of that is 5. 2 times 5 is 10. 10 is less than 7? No, it does not work. Okay, final answer. You'd say negative 7.5, bracket because it works, comma negative 0.5, bracket because it works. What I mean by works is, if I put it in, it'll actually make a true statement. It will be less than or equal to 7. All right, raise your hand if you would have got that one right. Okay, good. Who is so far acing the practice test? Like you would have had them all right. Okay, that's most of you. Now, some of you may feel like you would have aced it, but I answered it too quickly, and you don't really know for sure. You'll know more when you do your homework and check it tonight. Your homework has already been given to you. That packet I gave you before, the assignment is to finish it by tomorrow. I gave it to you on, what day was that, Thursday? Like on the day of the test, I gave you that review packet. All right. Next one. This one gets a little weird because it's got a square root in it. Anybody got an answer yet? Anybody got an answer yet? Yes? Doesn't work. What's the official name for that? No solution. Why doesn't it work? Because can you ever get a square root to come out negative? All right. How about if I put this on the outside? Can it work now? Yeah, because your first step will be to do what? All right, go ahead and try it. Okay. Squaring is easy because you don't have to worry about those absolute values. That's only if you square root both sides. So this is 36 equals x plus 4, and I just subtract 4 and I'm done. That is that easy. Okay? We're not likely to give you one that's that easy. Let's say it said x plus 6 squared. Let's say I change the problem like that. Then when you square both sides, some kids are going to go, oh, x squared and 36. That's easy. What's wrong with that? When you square something like this that's in parentheses, can you just take each of them and square it? No. You have to say x plus 6 and x plus 6. I'm telling you, even though I'm telling you right now, there'll be like, I don't know, 7 of you that are going to do that. You have to FOIL it out. You can say x squared outside 6x inside 6x makes a total of 12x and last 36 equals x plus 4. And this, man, have I said this a million times, you got to know how to solve quadratics. Quadratics keep on coming up. What do? You factor them. Can I factor it yet? No, first I got to do what? Put it all on the same side. Get it equal to 0. So this needs to come over, this needs to come over. And then I'd have x squared. When I take away x from both sides, I'll have plus 11x. And then the 4 gets taken away, and I get plus 32. And then we usually make them so they factor. And then you'll have 2 answers. And would I have to have a number line? No. You're looking for ones where there's a greater than or equal to thing, or a less than or equal to. So on this, there don't need to, if I could factor it, I'd just be done. I'd be able to say, let's say it was x plus 16 and x plus 2 or something. It's not going to actually work in this case. I can't factor it. If you get one that you can't factor, you have to use the quadratic formula. Okay, so let's say it had got to that, x equals negative 16 and x equals negative 2. I know this isn't the correct factoring for that, but I'm just saying if it had, then my two answers would have been these two things and I'm done. How do I know when to stop? Look for the sign. If it says equal to, you just want answers that are equal to and you're done. If it ever has a less than or equal to, think of it as the end of a number line. It'll remind you you need a whole range of answers. Okay. Next kind, domain. See if you could do this one. Find the domain of that. Another time you need a number line is if I say domain. Domain means gotta have a number line. Can't really do it without. I mean, you could, but it would be really dumb. Make a big number line and find the important points and check around them and all that stuff. I'll pause for a minute while you do that. Do you remember what I've told you about these, where usually kids get the intervals wrong, but they get the points right? Like, I bet all of you knew that -1 was one of your important points and that -4 was your other important point. Raise your hand if you knew those were the two important points. Good. Now here's where this separates the A's from the B's. Can you actually figure out, does it work at these points and does it work here, here, and here? All right, so does it work at -1? Why not? Because if I put in -1, what happens? It crashes. So empty spot does not work. Can I put in -4 or will it crash? Well, this one a lot of people get confused. -4 does not crash the bottom. -4 makes the top 0. Does that mean crashing? No, so it works. It does not crash it. Okay, next I test things like my favorite thing, 0. I put in a 0 and a 0 and a 0. Does it crash? Crash meaning 0 on the bottom or negative under the square root. No, it does not crash. It works. It does not make square roots negative and it does not make the bottom 0. Then if I try like -3, does that crash the top? No, it doesn't crash the bottom either, so it works. And the last thing, does -5 crash it? Yes, because as soon as I put in a -5 right here, right away, the square root has become negative and it won't work anymore. So, who had the intervals right too? Okay, good. That's less people, but at least vast majority of you seem like you know what you're doing. Good. Let's do one more kind. That was the domain. All right. Odd, even, neither. Does that seem to you like it should be odd or even? Even. Check it. Prove it. Prove it's either odd or even. No calc. Because if you could have a calc, you'd just graph it and see if it had symmetry like this, and you'd say, oh, it's even. But you can't use a calculator. If you've forgotten the rule, you won't get very far, so I'll help you. How many of you had the right rule? F of -x is equal to f of x. That's the even rule. You have the right rule? Good. Why are we testing even? Because the biggest degree, or the biggest power, sorry, and therefore the degree of this is even. So I'd test even first. Doesn't mean it's for sure even, just means that's the logical thing to check first. Now I'm going to stick in 3 empty spot to the 4th plus 1. Use all your variables, make them an empty parenthesis. Now I'm dropping in -x, and I see what I get. Negative, 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 negative. All the negatives are going to cancel. 3x to the 4th plus 1. Then f of x is this, and I put it in here. 3x to the 4th plus 1. Look at that. That is equal to that. If you don't have both sides exactly equal, then you won't get credit for saying it's even. You can't just have one side worked out. You have to have both sides worked out and actually equal to each other. Raise your hand if you knew that was even. Okay, good. And if I had tested and it was not even, could I assume it was odd? No, you then have to test the the odd rule, which for the record is f of negative x is equal to negative. I like to put parentheses, f of x. That's the odd rule. It's a little tougher, but because there's negatives on both sides, and that's odd. Get it? All right, good. Okay, now let's try horizontal and vertical asymptotes. Who tells you the horizontal ones? Bob. Bob will tell you why. And remember that if I just ask you which of the horizontals, can you tell me, y or x? The horizontals, and therefore the horizontals should say y equals whatever. Okay, and the verticals are the, what's the funny word? Zerticals. That'll remind you it's x equals things. Okay, and let's say that the problem looks like this. X squared plus 1 over x minus 5. What are the horizontals and what are the verticals? Horizontals are the Bob ones. Bob, bigger on bottom, bigger on top, same on both. Figure out what it is, make your horizontals. The verticals only come from the denominator. Remember, verticals only are from down here. Try it. Some of you aren't writing, it's making me nervous. Can't just think your way out of it. Okay, horizontals are the y things, the horizontals. So I'm going to say y equals, is this bigger on bottom, bigger on top, or same on both? It's a bot. What's the rule for bots? None. There are no bots. Next one, the verticals. That's the x equals things on the bottom. And what would make the bottom crash? 5, and therefore x equals 5 is my vertical. Okay, raise your hand if you understood that. Okay, good. Then let's move on to the last topic, which is domain and range based on a picture. Except we will not give you the picture. You'll have to be able to graph it yourself. Sketch what that looks like, and then tell me its range. No calculator. This is a sketch by yourself, like with your brain and the pencil. Remember, it doesn't matter that much, but that 3, stretching it a little bit, that won't change your range. Sketch that and tell me the range. What the heck, let's do the domain too. It's pretty easy. Just write down the domain also. Once you got the picture, it should be a piece of cake. Hopefully you know it starts as a V shape. And then where does it go? Right 2, and then what? Up 5. And then does the stretch really matter if that V is a little wider or narrower? No, it's not going to change your domain or range. Okay, so what's the range? It's from, well, how high up did I go? Up 5. Okay, I really should go up higher. If I did right 2, up 5, I should go more like that. There we go. Okay, that spot right there, it's not the 2, it's the 5. It's how high up it was. So it would be from 5 to, and it keeps going how far? Infinity. And does it work at the 5? Yes, and a lot of people got it wrong just because of the bracket parenthesis thing. When you're doing the range, if it can touch that number, if it can touch 5, and it can touch 5, then I have to put a bracket on the 5. So 5 to infinity, and the range, or sorry, the domain is from negative infinity to positive infinity, because the domain goes like this, and that's all reals, or negative infinity to positive infinity. Raise your hand if you got that one right. Good. I feel like you're pretty well prepared then. So now your question is, will you spend some time tonight practicing? I hope you will. Take that worksheet I gave you, check it against the answers that are provided. If you're stuck on stuff, come in the morning. I'm here, as long as it's not a Wednesday, which it's not. So I'll be here tomorrow morning. Feel free to work for the rest of the hour on your packet. If you have questions, ask me.